Hello everyone. So today we'll be presenting to you on experiment of batch liquid reactor. I'm Azrinisa binti Abdul Halim. We are going to move on to the abstract of the experiment. Okay, for the abstract, we are going to study the effect of temperature on the saponification reaction of ethyl acetate and sodium hydroxide. In this experiment, we are going to run for 2 times, one at 30 degrees C and the other one at 40 degrees C. However, our results are against the theories because the reaction rate and the rate constant at 30 degrees C is higher than the 40 degrees C. It should be vice versa. We can also find the activation energy or the slope using the graph of ln K versus 1/T. So that's all. I'll move on to my colleagues.
Hello, my name is Anand. I'll continue the presentation from my groupmate just now, Azri. Now I'll give you the introduction of this experiment. As you can see here, batch reactors are used for mostly laboratory scale. Actually, batch reactors came from a laboratory scale itself, whereby actually the reactors are placed in test tube or flask or beaker, heated or cooled in the beaker. The reaction is done in the beaker itself. After the reaction has occurred, the reactants and also the product will be poured out. Usually in industry, the difference between the lab scale and the industry scale of batch reactors is that the size and the quantities of reactant used are different. So batch reactors, they do not have any flow in and flow out. That means once the reactants is put in, then they will wait till the reaction is complete so that they can take out the products or the finished reactants. Next. Now I'll talk about the theory about this experiment. As you can see here, in the first part of this slide, I've mentioned that there's no feed or exit stream for batch reactors because it's not a continuous flow. So therefore, from the general mole balance equation, in minus out plus generation equals to accumulation, we will get this equation here, whereby the rate of reaction we will get from generation equals to 1/V and the accumulation there. So rearranging the equation, we will get rate of reaction times volume equals to NaO dx over dt. As you can see here in this above equation, it is dNA over dt. So the dNA, Na is equals to Na naught times Xa. So that is where we get this term here, and we bring out the Na naught as this is constant, and the Xa is the one will be changing according to our reaction that we are carrying out in the reactor. And batch reactors are usually used when a company wants to produce a range of products involving different reactants and reactor conditions. They can use the same equipment for this reaction. Okay, why they use for a range of products is because the reaction is fully completed. As not in a continuous flow reactor, as you can see, the reactants are continuously flowing, so not all of the reactants will completely react in the reactor. As in batch reactor, when it completely reacts, you'll have a range of products compared to the constant number of products. So next, I'll talk about the application. Here are some applications of the batch reactors. As you can see here, the first is small scale production of inducing fermentation of beverage products. Fermentation such as the yeast they use to fermentate food, sugarcane, all that they'll use batch reactors. As you can see, it takes long hours process. So these kind of reactors is very useful in that kind of application. And next will be this is in oil and gas industry, whereby we found out the application of membrane coupled sequencing batch reactor for oil produced water recycle. Basically water treatment, water wastage treatment. Usually we use batch reactors, and in oil and gas industry also we use for water treatment, wastewater treatment we use batch reactors. And finally, batch reactors also majorly used in medical production. Medical production, as in medicines, we tend to need a range of products from the chemical reaction. That's all from my part. Now I'll pass to my colleague here to continue the presentation. Thank you.
Hi there. After understanding the theories behind it, let's proceed to the methodology and how we can carry out the experiments. And now, This is how a batch liquid reactor looks like. There's a feed tank, 2 feed tanks over here, and this is the waste tank. And this is actually the reactor inside it, and this is the cooling water tank. Now, a reactor of the batch reactor must consist of the reactor first. The reactor must have a tank that bottom and that made of stainless steels, and it actually consists of the heater and temperature and the stirrer system. Then we have the feed inlet system, whereby we have 2 feeds in this experiment, and a feed tank is about 20 liter large. And after that we have the water batch, whereby the water will be used as a cooling water system. And the last will be the control panel as well as the data acquisition system. Basically, it's just computer system whereby we can proceed the data and produce a graph and controls the other process parameters such as temperatures and the pressure of the reactors. Now we proceed to the experiment procedures. How we can actually carry out this experiment to determine the effect of the temperature on the reaction. First, we need to prepare the reactants. The reactants we are using here is that 0.25 mole standard HCl and 1 liter of the 0.1 standard NaOH, which is sodium hydroxide. Now, this is how we prepared it. The method of preparation will be using titration. We use a small amount of the standard 0.25 mole of HCl. We are using the phenolphthaleins as the indicator, and using this titration method, we can produce exactly 0.1 mole of sodium hydroxide solutions, which will be the reactants of the experiment. Now, moving on, this is how we carry out the experiments. First, to begin our reactions that we have to pump in the reactants inside the reactors, and the temperature will be set to be 30 degrees Celsius, which is we have to compare the reaction between the 30 degrees Celsius and 40 degrees Celsius. So now, another liter of the 0.1 mole of the sodium hydroxide will be pumped inside the reactors as well. Then we will start the reactions between the sodium hydroxide as well as the hydrochloric acid. Now, the point when you start the experiments, the timer is started immediately, and after 1 minute of interval, we will record the data, and we will record the data inside a table. And the experiment is stopped right after the conductivity of the reactants seems to remain constant. What it means here is that the conductivity of the reactants will remain constant for over a few minutes, then we can stop the experiment. And then we will flush out all the reactants contents, because the reactants is actually reacted. Then we will put in exactly the same amount of the reactants again, and we set the temperature to be 40 degrees Celsius. And then we can obtain the different result for that, and we can compare. So this is for the experiment, this is for the procedures of the experiment, and now we will pass it to my colleague to proceed with the results.
Hello, my name is Harun Lazi bin Samsuri. Next, we will move to our finding of the experiment. So after getting some data for conversion and conductivity, we can see the pattern by constructing a graph of conversion against conductivity. So as we can see here, we can obtain the value of K by getting the slope of the graph. So as the conductivity increases, the conversion will be increased. Next, we also can construct a graph of x over CA0 1 minus x versus time. So here, as the time passed by, the value of x over CA0 1 minus x will also increase. So from here, we can construct a graph of ln k versus 1 over t. By getting the value of k from the slope before, from the first graph, we can get the value of energy. By comparing the linear equation from the previous graph and the Arrhenius equation, we can get the activation energy here, and we obtain 0.259 joules. for both temperature, however, the value of K are opposite with the theories. The theories said that as the temperature increase, the value of K will increase. But here, as the temperature increase, the value of K decrease. We move to the calculations part. So here we can get how we can get the X over Ca0 y minus X. First of all, we can get the mole balance for batch reactor, which is Ra over dCA over dt, and then we can obtain the rate law from the stoichiometry equation, which is minus Ra equal to KCA CB, and then we substitute the stoichiometry equation, which is the Ca equal to Ca0 y minus X, and finally we can get the equation here, y equal to Kt, which is K equal to X over Ca0 y minus X. So I think that's all from me. We move on to discussion part.
Hi, I'm Nadia and I will continue the part discussion. From discussion, we learned that theoretically the rate constant will increase as the temperature increase, but this is because when the temperature increase, the kinetic energy of the molecule will increase and the reactant will move vigorously to break the bond, and thus the reaction rate will increase. But somehow from this experiment, what we obtain is different from the theories. The result shows that as the temperature increases, the reaction rate will decrease. This is probably due to some errors in the experiment. The next one is conductivity. As time passes, the conductivity will decrease, and this graph shows that as convection increases, the conductivity will decrease. This is the same for both temperature. This can be explained by the conductivity of sodium hydroxide. Sodium hydroxide is a salt and it has higher conductivity. So it will ionize the ion and transfer the electricity to the reactant, to the product, which has less conductivity. Then as the sodium chloride concentration decreases as time passes, the conductivity will also decrease. But then the convection will increase. The next one, what we obtain from the experiment is activation energy. From what we can see here, we can plot the graph ln K versus 1 over T. And then from the slope, and using this equation, we can get the activation energy, which is 0.259 joules. Okay, so this reaction is called saponification, and it's supposed to form a soap as the final product. But somehow the reactant is at low concentration, and then the soap cannot be formed. Then we move to the error of the experiment. From the experiment, we have 3 errors. First one is when we try to keep the time interval, we tend to overextend the time interval, and then the negligence may affect the result of the experiment. The second one is the temperature of the reactor is not constant from time to time, and then it will also affect the result of the experiment. So my recommendation is that the tank should be removable to ease the washing process, and the second one is that the concentration should be checked by titration so that it will be more accurate. That's all from me. Thank you.
So in conclusion, what we got is that the rate constant at 30 degrees C is more than the rate constant at 40 degrees C. This is against the theories. However, we can conclude that the temperature actually affects the saponification process of ethyl acetate and sodium hydroxide. According to the theory, as the temperature increases, the rate constant should increase. However, we obtained otherwise, maybe because of the error in the experiment, as what my group mate has told you earlier. So We have used all these books as our references. Thank you for watching this video.